Alright guys, now we're moving on to Charles' Law. If you noticed, I've uploaded simulations to our classroom. Go ahead and explore those, check those out, especially the ones uh, that pertain to Boyle's and Charles' Law. Those hands-on simulations will definitely help your mind to just grasp the material that we're covering. So it'd be really good. And keep in mind that it's all according to the kinetic theory. Therefore, we're dealing with gas particles. So that's every lesson and every simulation is based upon that theory, and that's what we're going with. And just keep that in the back of your mind as we continue to explore these gas laws. So now Charles' law. This law deals with the relationship between the volume of a gas and the temperature of a gas. The relationship between the two, they're considered directly proportional, which means if volume increases, temperature increases. If volume decreases, temperature decreases. In those simulations and in Charles's experiments, he used a sealed container with a piston that would go up and down, and that's how he would observe the relationship between the volume and temperature. He would increase the temperature and the piston would rise and the volume would increase, and when he decreased the temperature the volume would slide down and the volume would decrease. This is all based upon the kinetic energy and the rates of speed that these particles are going in. If you increase the temperature, that means the particles will get faster. If the particles are getting faster, then that means the force against the walls are bouncing harder against the walls, which bounce and push against this piston, which would increase the volume. And the same thing, if you decrease the temperature, the particles will slow down. Thus, there's not that much force against the piston wall, and the piston would decrease and go slide down, thus decreasing the volume. After the experiments, he came up with an equation. I rearranged it once again for you. Memorize this one. And trust me, it's way simpler the way this is. Memorize this as well as Boyle's law. And here it is. Your new equation. V1 T2 equals V2 T1. So initial volume times final temperature equals final volume times initial temperature. So there's your equation. Okay, you can push pause and write that down real quick. I'm going to go ahead and give you an example now. Y'all ready? All right, here we go. Here's a sample problem for Charles' Law. Here in this problem, a container holds 50 milliliters of nitrogen at 25 degrees Celsius and a pressure of 736 millimeters of mercury. What will its volume be if the temperature increases by 35 degrees Celsius? Now, this is a point that you need to remember now because this equation, yes, it deals with temperature, and in this problem, this is degrees. The temperature is in degrees Celsius. You have to remember that when you put these in your equation, you must convert to Kelvin. You have to. It will not work if you do not convert to Kelvin. All you have to do is add 273 to whatever the degrees Celsius is, as long as it's Celsius. So here, let's identify which one's which. Volume and temperature. V1, V2, is it T1, T2? Let's figure that out first. And keep in mind the volumes in milliliters. You will see different units for volume. You can see milliliters, liters, cubic, centimeters, all those different things that are volumes. As long as the units are constant, then nothing changes with your equations. Just make sure you're dealing with the same units. And same with pressure. You'll see millimeters of mercury here. You see kilopascals, pascals, atmospheres. As long as you just keep them constant, it doesn't mess with the equation. Temperature is the only one that you actually do have to convert the temperature scale to Kelvin. So here we go. So we have a container holding 50 millimeters of nitrogen. Millimeters, that's a volume. Okay, let's see if it's V1 or V2. It says here, what will its volume be if the temperature increases by 35 degrees Celsius? That means the initial volume will be 50 milliliters. This is V1. Initial volume, that's the starting point. We want to know where it ends when the temperature increases. All right, so and also if it increased by 35 degrees, that's T2, and 25, this is T1. It's T1, it started at 25 degrees Celsius. We will increase it by 35 degrees, meaning the final temperature will be 35 degrees warmer than 25. That means that's T2. Here, 736 millimeters of mercury, that's the pressure. It doesn't change. Pressure is constant in Charles' law equations. Pressure is constant. Remember that. That is also a test question. So here we go. Let's set up our equations. So we know what we're looking for here. We have V1. We have V1 here equals 50 milliliters. V2, we're searching for. T1 equals 25 degrees Celsius. T2, and this is increases by 35 degrees Celsius. And so just because it's just because we're not, T2 is not 35 degrees. We increase 25, we increase from 25 and we increase to 35 degrees. And so therefore we're going to add them up to 80 or 30, 50, 60 degrees Celsius. This will become 60 degrees Celsius. That's 35 degrees Celsius warmer. Now we convert these to Kelvin by adding 273. And that answer, let's see, add this is 333 degrees Kelvin, and this is 258. I'm reading off my notes here. All right, so let me double check that. Nope, 298. All right, so now plug it into your equation. So we have V1 50, T2 V2, we have no idea, and T1 298. All right. So our goal is to find V2. It's a simple rearranging equations. We want V2 by itself. So you're going to divide both sides by 298. Those cancel out. You divide that by 298. And now we're taking 50 times 333. Divide that by 298. And our answer for V2 should be 55.9 milliliters of nitrogen. So 55.9 milliliters. So therefore, it went from 50 to 55.9. That's an increase in volume. The temperature increased, the volume increased. That's an easy way to check your work. As long as it stays directly proportional, you know you did it right. If we showed a lower number than 50 milliliters and it went down when the temperature increased, that's not the right relationship. That means your answer is wrong. But here, this is your correct answer. 55.9 milliliters of nitrogen. That's V2. And remember, it's the same principles here. V1 T2 equals V2 T1. For that one, we solve for V2. Let's say we needed to find the initial temperature. So we're looking for the initial temperature. Well, you need initial temperature by itself. Just divide both sides by V2. And it's just simple. You just you just want to get it by itself and rearrange to get your answer. Remember, the biggest thing is convert to Kelvin. This one's a little different type of problem because it just increased 35 degrees Celsius. Usually they just straight up tell you what the temperature is and then you just add your 273, so it's a little bit easier. Also, sometimes you'll see a problem where it wants the answer in degrees Celsius. So you have to still convert to Kelvin, but at the very end, if it wants temperature in Celsius, you just subtract by 273. I'll work through some more practice problems, so don't worry. This is our first one. And then we'll just continue on. You'll see a worksheet. Go through those simulations this week, and then let's just progress through this chapter. See you guys.